Hi everyone, a very good evening to all of you. My name is Ashna Sisodia and today we are going to talk about what is an orbit and how many types of orbit are there. This topic is particularly important for space technology. The basics we'll try to understand today, and in science and technology section, space technology is an important part. So let's start with what is an orbit first of all. Now, an orbit is a regular repeating path that one object in space takes around another one. An object in an orbit is called a satellite, and a satellite can be natural, it can be like Earth or the moon. Many planets have moons that orbit them. A satellite, however, can be man made also, like the International Space Station. So, planets, comets, asteroids, and other objects in the solar system, they orbit the sun. And most of the objects orbiting the sun, they move along or close to an imaginary flat surface. And this imaginary surface is the ecliptic plane. Therefore, this can be defined as a path that an object takes as it revolves around another object in space under the influence of gravity. And the most common example of an orbit is the path that a planet takes around a star, such as the Earth orbiting around the Sun. And in order to maintain an orbit, an object must be moving at a certain speed and at a certain distance from the object that it is orbiting. The shape of an orbit can vary depending on number of factors including the mass and shape of the objects that are involved. But for us, what is important is how do these objects stay in orbit? An object in motion will stay in motion unless something pushes or pulls on it. And this statement is called Newton's first law of motion. Without gravity, an Earth orbiting satellite, it would go off into space along a straight line, or with gravity it is pulled back towards Earth. So there is a constant tug of war which takes place between the satellite's tendency to move in a straight line or momentum and the tug of gravity pulling the satellite back. Then let us try to now cover the types of orbits now that we have understood what is an orbit. So there are a number of types of orbits. We have geostationary orbit, we have low Earth orbit, medium Earth orbit, polar orbit, and sun synchronous orbit. Then we have transfer orbits and geostationary transfer orbit and Lagrange points that are also known as L points. So first of all, let's deal with geostationary orbit. See, upon launch, a satellite or spacecraft is most often placed in one of these several particular orbits around Earth, or it might be sent on an interplanetary journey, meaning that it does not orbit Earth anymore, but instead orbits the Sun until its arrival at its final destination, like Mars or Jupiter. So there are many factors that decide which orbit would be best for a satellite to use, depending on what the satellite is designed to achieve. And first of all comes this geostationary orbit. Satellites that are kept in geostationary orbit, they circle Earth above the equator from west to east, following Earth's rotation, taking 23 hours, 56 minutes, and 4 seconds by traveling at exactly the same rate as Earth. And this makes satellites in geostationary orbit appear to be stationary over a fixed position. And in order to perfectly match Earth's rotation, the speed of geostationary satellites should be about 3 kilometers per second at an altitude of 35,786 kilometers. You know, this is much farther from Earth's surface compared to many satellites. The distance here is going to be 35,786 kilometers. So roughly we can say 36,000 kilometers far. Geostationary satellites is used by satellites. This orbit actually is used by satellites that need to stay constantly above one particular place over Earth. For example, for telecommunication satellites, this way an antenna on Earth can be fixed to always stay pointed towards that satellite without moving. And it can also be used by weather monitoring satellites because they can continually observe specific areas to see how weather trends emerge there. And satellites in this orbit cover a large range of Earth, so as few as 3 equally spaced satellites can provide near global coverage. It can provide a global coverage. This is because when a satellite is this far from Earth, it can cover large sections at once. And this is akin to being able to see more of a map from a meter away compared with if you are just a centimeter away from it. So to see all of Earth at once from geostationary orbit, far fewer satellites are needed than at a lower altitude. Then next let's try to understand what is the difference between geostationary satellite and geosynchronous orbit. Actually, geostationary orbit, this should be orbit, not satellite. Although the terms geostationary and geosynchronous are often used interchangeably, they actually refer to slightly different types of orbits. Because a geostationary orbit is a specific type of geosynchronous orbit where a satellite's orbital path is directly above the Earth's equator, and the satellite is positioned in such a way that it appears to be stationary relative to an observer on the ground, which means the satellite always remain in the same position in the sky, allowing it to provide constant coverage of a particular area on the Earth's surface. But in contrast to that, a geosynchronous orbit is an orbit that has the same orbital period as the rotation of the Earth, which is approximately 24 hours. This means that the satellite appears to remain stationary relative to a fixed point on the Earth's surface, but it may not necessarily be directly above the equator. So in other words, we can say a geostationary orbit is a specific type of geosynchronous orbit, but not all geosynchronous orbits are geostationary. Now let's try to understand what is a low Earth orbit. See, a low Earth orbit is, as the name suggests, an orbit that is relatively close to Earth's surface. As the name suggests, it is closer, which means it is normally at an altitude of less than 1,000 kilometers, but it could be as low as 160 kilometers above Earth, which is low compared to other orbits. So if you look at the geostationary orbit from Earth, that is going to be roughly 36,000 kilometers. It's very far. And low Earth orbit is going to be just this far. So by comparison, most commercial aeroplanes they do not fly at altitudes much greater than approximately 14 kilometers. So even the lowest low Earth orbit is more than 10 times higher than that. And unlike satellites in geostationary orbit that must always orbit along Earth's equator, low Earth orbit satellites, they do not always have to follow a particular path around Earth in the same way. Their plane can be tilted, which means there are more available routes for satellites in low Earth orbit, which is one of the reasons why low Earth orbit is a very commonly used orbit. Because of its close proximity to Earth, it makes it useful for several reasons. It is the orbit most commonly used for satellite imaging, as being near the surface, it allows it to take images of higher resolution. It is also the orbit which is used for International Space Station, as it is easier for astronauts to travel to and from it at a shorter distance. So satellites in this orbit travel at a speed of around 7.8 kilometers per second. Then we have medium Earth orbit, which consists of a wide range of orbits anywhere between low Earth orbit and geostationary orbit. Right, so this is actually quite similar to low Earth orbit in that it also does not need to take specific paths around Earth, and this is used by a variety of satellites with different applications. But this is very commonly used by navigation satellites. Navigation satellites like we have Europeans Galileo system, and Galileo powers navigation communications across Europe, and this is used for many types of navigation. Like if you want to track large jumbo jets to getting directions to your smartphone. So it uses a constellation of multiple satellites to provide coverage across large parts of the world all at once. And then we have the polar orbit. Satellites in polar orbits usually travel past Earth from north to south rather than from west to east. These are going to pass roughly over Earth's poles. So satellites in a polar orbit do not have to pass the north and south pole precisely. Then we have sun synchronous orbit. This is a particular kind of, it's a type of polar orbit, you can say that. And satellites in sun synchronous orbit traveling over the polar regions, they are synchronous with the sun. This means that they are synchronized to always be in the same fixed position relative to the sun. They are fixed relative to the sun, which means that the satellite always visits the same spot at the same local time. For example, passing the city of Paris every day at noon exactly, which means the satellite will always observe a point on the earth as if constantly at the same time of the day, which serves a number of applications. It means that scientists and those who have been using the satellite images can compare how somewhere changes over time. This is because you want to monitor an area by taking a series of images of a certain place across many days, weeks or months or even years. It would be not very helpful to compare somewhere at midnight than at midday. So you need to take each picture as similarly as the previous picture as possible for this to understand. And then we have the transfer orbits and the geostationary transfer orbit. Well, about this, all I can say is transfer orbits are the special kind of orbit used to get from one orbit to another. So when satellites are launched from Earth and carried to space with launch vehicles, the satellites are not always placed directly on their final orbit. Often the satellites are instead placed on a transferred orbit, an orbit where by using relatively little energy from built-in motors, the satellite or spacecraft can move from one orbit to another, as you can see in this picture itself. So this allows a satellite to reach, for example, a high altitude orbit like geostationary orbit without actually needing the launch vehicle to go all the way to this altitude, which would require more effort. This is like taking a shortcut actually. So these are the type of orbit that I wanted to discuss today. This is it for this video, guys. Thank you very much. I'll be coming up with more such videos in future. Bye bye. Have a nice day ahead.